So greetings to all the attendees attending from various geographic locations, and hope all are staying safe. So in this session, what we are going to talk about is maybe quite significant, we would call, because it's going to be a little more comprehensive enough, where we are talking about our new release, MeshWorks 2020, and together with the CAE Process Automation, how the engineering platform that is MeshWorks 2020 is relevant for not just Industry 4.0, but also for the Industry 5.0 type of activities that you foresee in your future workflow. So having said that, we would go into the next slide, which sort of lists you the content that we have structured for this webinar. I'm joined by my colleague Abdul. He's going to walk you through the steps of how process automation is done and how this is very relevant for design exploration and other activities that are part of your simulation work for Industry 5.0. So the first and foremost point that we will discuss today is MeshWorks as a pre and post. And what are all the key differentiators? What is the perspective with which we can look at MeshWorks 2020? So we would want to talk about that for a few minutes. And then we would lead into the session with a preview of how the process automation in MeshWorks could be shaped up and can be a great enabler for you. Today, we have picked up a CFD example of an internal flow, and we want to share with you how your model-based system engineering work at a 1D model level can really help you to realize a 3D model through a process automation in MeshWorks 2020, and how we can parameterize that CFD model so that we are getting it ready for design exploration. And after we explore the design, assume that we have reached a good optimal point in terms of the flow characteristics, then we will be able to complete the loop by taking all the learnings from the optimized CFD model and putting it back into the CAD so that we have an optimized CAD also made available. So this is exactly the topic that we are going to address, and it is enabled by our process automation pillar of MeshWorks 2020. So going into the next slide, which is to introduce you about MeshWorks 2020, to make it very easier and comprehensive for you, what you see on the right-hand side of the slide was the leadership area of MeshWorks in its earlier releases. So the focus was on morphing technology and the leadership in that area, and then the CAE model parameterization, that is the FE-CFD model parameterization. We're not looking at only shape parameters, we are looking at entire way to parameterize shapes, size, materials, welding, adhesives, and even the design features like bulkheads, doublers. So we were looking at a variety of parameterization options, and that was a key advantage of using MeshWorks. And together, the morphing technology and CAE parameterization was greatly enabling design optimization. We were working with several partner tools of ours, including iSight, Mode Frontier, for example. We were enabling the optimization workflow for our customers who are at the early stage of their product development and also even downstream stages of the product development. Now, with just the penultimate release of MeshWorks, what we introduced are two important pieces that you see in this slide, which is the pre and post-processing functionality of MeshWorks. And also we have really brought in the process automation, where the engineers who use the tool can build automation by themselves without having to be an expert in programming language. And that's a very important differentiation or a change that we wanted to bring in. And that is also available as part of MeshWorks 2020. And the most important latest tool sets that we have brought to MeshWorks 2020 is ConceptWorks. And this is a great advantage to the product development process, where we are developing products that are predominantly based on sheet metal components and assemblies, or cast components, or forged components, or even plastic components. We've created a set of tools and functionalities which will really make it easier for CA engineers to explore concepts. The key is with MeshWorks 2020 is explore the design, and that is the agenda that we wanted to present to you. And this is what is MeshWorks 2020 tool set for you. Now, going into the next slide, we will bring up to you the 4 critical differentiating pillars of MeshWorks. That is the integrated modeler, automated modeler, associative, and parametric modeler. These are the 4 important critical differentiating features, as you can call it, for MeshWorks 2020 as well. And these advancements are continuing. Even in the earlier release of MeshWorks, we had a clear focus on these areas, and this focus is only getting better so that users can really leverage the benefit that they can derive under the Industry 4.0 umbrella itself. And in today's demonstration of process automation, you are also going to see the glimpse of important pieces of the puzzle here. That is the automated modeler, where we create process automation, and parametric modeler, where the CFD model is made parametric and enabling design exploration. So you're going to explore 2 pillars today, and down the line in other webinars, we will definitely bring your attention to all the other important tools, especially integrated modeler and associative modeler, and share with you the benefit. Now, having created all these set of tools under MeshWorks 2020, in the next slide, you will clearly see how we are trying to address the various stages of the product development. What is it that our message is from the perspective of MeshWorks 2020 and process automation? In this context, what you're seeing here on the screen is an automotive example where the product development starts all the way from the concept and goes all the way into virtual verification and validation phase. And we see, and we are all aware that the trend is more simulation upfront. This is what is the trend as of Industry 4.0. This decade has seen tremendous change in this, and there is a obvious, not just the necessity, but the benefit the OEMs have realized in terms of doing more simulations upfront, so that the cost of the changes are kept under control, under minimal, and we have fairly explored the design space quite well. True to the tradition, MeshWorks is enabling this exact objective of the product development organizations. We enable front loading or more simulations upfront. Through our morphing technology, CAE parametric technology, we were enabling users to create several CAE CFD models so that we could really explore the design space and study where the optimal lies. And once we do those extensive evaluation at the concept stage, we are ready to go into the next stage where we can use MeshWorks tools to build or put together or mesh and assemble models. And then again, put on the parametric engine on, and then we'll again be ready to explore the design even more and see where our optimal lies. And we could continue that even into the verification and validation stage, where we couldn't do major changes to the shape or geometry, but we still have the freedom to change some of the aspects towards the welding, or some of the aspects towards the doublers and other components, which are pretty much helping us to bridge the performance gaps, if at all any. So this entire workflow from concept until the virtual validation and verification phase is nicely enabled by MeshWorks and the tools in MeshWorks 2020. And process automation is obviously a common denominator in all the phases, which really help us accelerate simulation. So having said this, we would straight away jump into today's topic so that we can lay the contour of today's discussion, how it is going to go through. One of the important aspects that we want to demonstrate to you today through this process automation as an enabler is to make sure and bring to you the message that as MeshWorks 2020, we are ready for your focus on Industry 5.0. And how do we do that? Our process automation engine in MeshWorks 2020 is going to enable creation of workflows. And through these workflows, we are able to generate models faster. And together with parametric modeling, we are going to help you explore design. And our objective is to arrive at a solution. And also, this entire workflow and design exploration is kept independent of industry verticals, means it is applicable to several industry verticals. And that's the good point that we want to demonstrate to you today. Even though the example is a CFD model, but that is the message that we want to bring up to you today. We also want to bring your attention to one of the important aspects that as Industry 4.0 and 5.0 we are realizing. We are realizing the potential of a reduced order model. It is not necessary that all the simulation workload has to be taken by the 3D model evaluation. We should have an intelligent use of 1D and 3D models, and if need be, the interchange of one between the 1D and 3D models. This is going to be very important part of design exploration. And today we've made an attempt to share our experience with you in that side and how process automation is very important so that it forms a bridge between those two. And also we want to present you the benefit of how easier it is to create process automation in MeshWorks. And lastly, we want to also address the topic, having explored a design with MeshWorks' parametric modeling. Now, how do we translate our optimization output back to the CAD team? How do we make it work and complete the loop and make it a closed loop solution? And that is exactly what my colleague Abdul is going to demonstrate with you. He is nicely going to follow the 4 blocks that you see as a flow chart in the illustration below. And I would now hand over the stage to Abdul so that he can walk you through and explain how we can really envision MeshWorks 2020 to be that enabler for you if you are looking at this kind of a workflow to save time. Over to Abdul.
Yeah, thank you so much, Karthik, for the very brief and nice introduction. I hope everyone can hear I'm audible to you. Can you confirm, Karthik?
Yes, your voice is very clear. Please go ahead.
Yeah, thank you, Karthik. So good morning and greetings, everyone. So we welcome you all for this MeshWorks 2020 webinar series. So today's topic will be like our great privilege to showcase you all about the automation capabilities from MeshWorks. So as you can see in this slide, like so today we are going to start an automation to illustrate the entire demonstration of how automation has been created into process workflow, and how to create a process automation, and how we are doing a design validation into it. So this is a process we are going to showcase to you today as a topic. So what you are seeing in the display is an HVAC duct automation. So HVACs is like a common topic, like which is applicable for construction HVAC, or either it might be an automotive HVAC or aerospace HVAC. So any HVAC system it can be applicable for. So our process is very simple, but the manual process is too long. Let's say so is from your output. So system tool, so which is like a GT power kind of a tool. So where we have all the sectional properties of 1D elements. So with that particular 1D sectional properties, we wanted to generate a 3D CAD surface. So with the 3D CAD surface, so we need to do the modeling process. So how, in the sense, like from the 3D CAD, we need to isolate the wetted surfaces. So where the air flows are going to be, and then we are going to enclose the wetted surfaces and do the meshing for it. So where the simulation going to be. So the meshing till the tetra meshing, it's need to be taken care by the automation. So which is an straight away workflow for all the kind of ducts which the particular OEM is following up. So this workflow is completely automated now, which is a very simple and easy way of creating an automation. Okay, so what is the panel you are seeing here is one is the creating and generating of a 3D CAD surface, and then it is going to be the wetted surface extraction panel, then it is going to be the meshing and modeling panel. So this is like nicely created panel, so which is specific for this particular duct automation. Okay, so what is this automation is so we created, so we'll just showcase as the demo now. So initially, the user is going to select a type of HVAC ducts. So which is like he has some multiple number of ducts in it. So we are going to select a special shape duct. So and import a CSV file, so which includes all the sectional 1D properties of which is from our output tool. so GT Power or some other tool. Then so from there, like we are going to import that particular CSV file and say execute. So in this particular execute button, the user is going to do all the process in the manual way, which is like drag, spin, or any functions. So we are just including all the functions into it. So which is like, it seems to be just an execute button. So but it is a all the manual process we have automated and kept it in that particular execute button. So how we are aligning that processes into this execute buttons, like we are going to showcase in the next slide. Okay, so first, after executing, like the user will be getting the output of a 3D CAD, so which is with the sectional properties of all the like radius of angle and the length of the each section. So everything he will be getting a output. So from there, the user wants to isolate the wetted surface region. So for that, the user needs to select the CAD surface here and say isolate wetted surface. So it nicely identifies the internal flow region so as a wetted surface region, and isolate it and give it to you as an output. Then the user is going to select the CAD surface for meshing. So where it needs to be enclosed for the simulation process and the parametric process. So we are just identifying the open ends and we are closing it. So and it just say open close in, it is going to be get closed. Then we are going to import the mesh template here. So mesh template as per the user's definition. So how the user wants, as in like so here is the mesh template, so which we are importing inside. So this mesh template has all the information about so what is the element size, minimum element size, maximum element size, the quality. So all the general input parameters, so all it will be there in this particular template. And also like what is the meshing criteria, like layer tetra meshing. So all those criteria also, like for the tetra mesh, we will be giving into that particular template. And we just say generate mesh. So it is nicely going to mesh this entire model, and it is going to clear the quality. So then it is going to produce the tetra mesh as well. So we'll do the correct section and showcase you like how it is being meshed inside. So it will also take care of the layer tetra meshing into this particular model. So this is the output of this entire model. So for this particular process, the user, if it is taking a manual method, in the sense he needs to prepare a CAD itself, he would take a lot of time. So from there, he needs to clear the CAD surface quality. Then he needs to go with the meshing process. Then meshing also, he needs to clear the quality. Then he needs to go for the 3D meshing. So all these applicable as a manual process, which is like has been done in a minute or so. So this is like the entire workflow of this HVAC duct. So which is very simple and more efficient way of doing this automation. So for the next slide, we are going to show you like how we create this particular automation for the HVAC system. So we have taken an example of this wetted surface isolation itself. So which is one of the panel of the past slide. So I'm just going to showcase this as a demo. Just a minute. Yeah. So the user is going for the go to designer panel, so which is the panel creation tab. So from there, the user is going to select the panels, like so what is the naming of that button. So then the button of the selection button. So and he is going to give the properties. So what is that particular button needs to be get selected with, like elements or CADs. So CAD surface. So all those information we are feeding in here, and the execute button and the reset button and the return button. So all this like so it's all like a customizable, and so as you can see it here, like we can do all the adjustments, and it's look like the original panel itself. And then the user is going to import the recorded process here. So this entire process automation is just a 4-step process, which is recording a workflow of a particular process. So the manual way of process, and we are going to just plumb it as a panel, as you can see it here, and then we are going to publish as a panel. So this is like a simple way of creating a panel. So as you can see here, like it is being created now. So the user is going to do this as a like a small workflow kind of a thing. So he is going to convert it into an automation very quickly and efficiently. So for this particular automation building, the user does not need to learn any languages like TCL, TK, or Python to do this. Like we have our own language to do this entire process. So, and also like it is very easy way to create the automation itself. So this is a particular way we created that entire automation. So creating the automation also, it's very easy. So even just a training of MeshWorks, like the user can build the automation on himself. So next is like once the automation is completed and the HVAC system is been with us, like so we have done all the meshing, and so after the meshing, so we all know like the entire meshed in MeshWorks get parametric after doing the meshing. So we have created some couple of parameters, so which we wanted to show you here. So it is all like a number of 5 parameters. So where the user wants to increase or decrease the width of the outlet duct parameter. So it doesn't like after the constructional details, like if you wanted to any changes of packaging, so it wanted need to be changed or modified, so we can do it according to it. And also based on the flow, the diameter of this entire tube can be changed. So this is also one parameter which we created, so which is a duct tube parameter, and also the duct length parameter. So this is also based on the length and packaging, like if at all any constructional pipes or drainage holes are going, pipes are going through it, and we wanted to extend this particular tube to a distance, so then it is going to be another length of parameter. So then the outlet angle, so this is also based on the packaging only, like so based on like how the duct is going to be sit into the cabins. So based on that, like it is going to create a outlet duct angle. So these are the number of parameters so which we created here. So as you can see the animations in it. So these are like seems to be very simple and more efficient and very effective parameters which we created into it. So once after creating all the parameters, so these parameters can be used as a parametric model based architecture of optimization technique. So where the user can build a baseline design, so which is a CFD model. So from there, the user can, from the baseline model, he can generate multiple number of parameters into it. So a number of parameters he can create into a model. So from there, like the user can generate a DOE, so which is a design of experiments. So where he can generate multiple number of designs. So design 1, 2, 3, and still the n number of designs based on the probabilities of the variables as well as the parameters. So from there, like it is going to be solved in a random way in a CFD solver. So from there, it is going to be get input output matrix, and the DOE table also will be generated into by MeshWorks itself. So from the DOE table, like we can just get into input output matrix. So from there, like it is going to an optimizer tool, which is our eyesight, Tosca, or more frontiers. So we can give the design variables and limits into that, and then we can go for the calculation of response surface. So from the response surface calculation, so with objectives and constraints, so the user will be obtaining an optimized design at last. So this is a workflow which is a more effective and efficient way, so which we are following in right away. So it's applicable for CAE and CAD morphing parameterization and multidisciplinary weight optimization. So and also like so the next slide would be like our MeshWorks interface. So with all into put in together as our baseline CFD or a CAE model. So from there, like a design of experiments table and design variable. and model parameterization, we would get a multidisciplinary model generated from MeshWorks 2020. So this is like a very, very easy and clear way of a flowchart where you can do the modeling process, morphing process, and parameterization, and do the optimization very quickly and efficiently. So on generating all this model after the optimization results also, it is like very easy. Once after DOE table has been created, so we can generate all the 55 designs or more than that in a batch mode process. So which is completely automated and fully robust way. So once after, like if you are generating all, finally got an output of an optimized design. So that particular optimized model design, so you wanted to convert it into a CAD again. So we have a solution for that as well. So which you will be seeing it in the next slide. So which is a CAD morphing technique. So which is our patented technology again. So which is CAD morphing of an HVAC duct system. So here the user needs only few inputs, so which is your original CAD model and the mesh output of an original CAD model and the optimized model. So the optimized model would be your so which is came from your DOE and so the multidisciplinary optimization. So this particular model, we are going to have it as an input. So with these three input, the user is going to get an modified optimized CAD itself. So the panel you are seeing it in the below is your CAD morphing impose deformation panel, where the user is going to select the CAD surface, and then he is going to select the original FE data, and then he is going to select the optimized FE data, which is a CFD model, and he is going to say impose. So whatever the changes which has happened in the optimized design, either like length of the duct or diameter of the duct or the width and height of the outlet ducts. So all these parameters going to be identified through original mesh data and going to be applied on the CAD itself. And it's going to give the output of the modified and optimized output. So this also, like, we will show it as a demo itself. So as you can see, this is our CAD morphing panel. So here, like, we will just go for our CAD morphing tool, and we'll just convert this into a resolution. So after just converting this CAD, like, we are going to do the impose deformation technique, so which I have explained already. So we are going to select the CAD surface and select the original FE data and the optimized FE data and just say impose. So that's it. Like, it is going to give the output of a optimized CAD data itself. So this CAD data itself, it will be output of directly into the from the optimized mesh data. So this is an overall workflow. So where the user starts from nowhere, like with the 1D sectional properties, he is going to generate the mesh CAD data into it. From there, he is going to do the mesh data. Then he is going to convert that into a parametric file. So from that parametric file, he is going to generate the CAD data itself. So it is completely A to Z process, which is more optimistic process, which is followed by our tool. So overall, like our MeshWorks key takeaway points will be conveyed by Mr. Karthik. Karthik, you can take the stage over, Karthik.
Thank you so much, Abdul. I think you covered the whole 9 yards for me, making the last slide very easier. I think what was very visible to you was the focus of MeshWorks 2020 in terms of how easier it is to create process automation. So it was demonstrated as though it was just pulling together a few buttons, associating functions to those buttons, and creating a flow chart of input and output, and you are done with it. So it was pretty easier. And what it got accomplished today is through this process automation, we are able to put together a workflow. So we are able to look at the systems engineering level model and get the output in an Excel sheet in the form of a CSV file or any of the easier formats, and that is readily portable. And the process automation in MeshWorks can pick up the values from there and convert that information from system model in terms of area, length of the duct and everything into a 3D model. And from then on, the meshing tools in MeshWorks come into action, and then the parameterization tools in MeshWorks come into action. All these are sequentially organized in terms of the workflow. So that is what is the central takeaway point. So if you are looking at achieving a solution starting from a system level and going all the way till in a very structured manner and a very systematic manner, MeshWorks 2020, you are looking at a very good tool set in that sense of enabling the creation of workflow, enabling to explore design, and also easy to create process automation, which makes the entire process really a great time saver. See, the as an industry 5.0 perspective, if I look at it, be it automotive, as Abdul said, or aerospace, or even for that matter, the farm and construction equipment cabins where HVACs are available these days, or for that matter, the HVAC in a building environment where we are trying to set up a data center, for example. In any of these situations, we need the ability to quickly go from the system level requirements back into 3D and also explore the design space and again come back to the system model. We need to do this much faster. And MeshWorks is readily available for that design exploration and also have a very structured workflow. These are two important things of Industry 5.0. You should have a seamless flow of data, seamless connectivity established, and this is enabled by MeshWorks 2020. So you could remember the MeshWorks 2020 process automation as an enabler of a workflow, which walks you through from the connects the system level model to the detail level model, and which walks you from the concept all the way to the solution for your design problem. So these are the takeaway messages that we wanted to leave you with.